10 strange things happening in the universe right now. Something is off. Not in the distant future. Not in theory. Right now. Across the universe, objects are appearing where they shouldn't exist. Energy is reaching us from places it should never escape. Signals are arriving that challenge everything we think we know about physics. Some of this sounds like science fiction, but every story in this video comes directly from real observations. Today, we're looking at 10 strange things happening in the universe right now. Discoveries that are quietly reshaping our understanding of reality. 1. We are tracking something that shouldn't be here. Astronomers around the world are currently watching an object that doesn't quite make sense. It entered our solar system from interstellar space, moving far faster than most known comets. Its trajectory points back toward the constellation Sagittarius, and its speed suggests it could be older than the solar system itself. The object is known as 3I Atlas. Officially, scientists classify it as an interstellar comet, but its unusual motion immediately caught public attention. Online, speculation exploded. Some people suggested it could be a probe. Others called it a scout, or even a message. Researchers dismissed those ideas. Still, they admit the object is unusual enough to deserve close monitoring. In 2026, Atlas will pass near Jupiter. That encounter could dramatically alter its course, either ejecting it from the solar system or sending it in a new, unexpected direction. 2. Something is launching high-energy particles at us. Earth is constantly being bombarded by particles traveling at nearly the speed of light. They're called ultra-high energy cosmic rays. When they hit the atmosphere, they explode into showers of secondary particles, leaving behind detectable traces. That's how we know they exist. What we don't know is what fires them. Supernova are a strong candidate. So are black holes, neutron star collisions, and the cores of active galaxies. The problem is that these particles twist through magnetic fields during their journey. By the time they reach Earth, all information about their origin is erased. We know we're being hit. We just don't know by what. 3. Gamma rays we shouldn't see reached us anyway. In 2022, space lit up with the brightest cosmic explosion ever recorded. A distant star collapsed into a black hole and released a gamma ray burst so powerful it earned the nickname, brightest of all time. Some of the detected gamma rays carried more energy than our models say should survive a journey across billions of light years. According to known physics, they should never have reached us. Yet they did. One possible explanation involves dark matter. Some theories suggest gamma rays may interact with exotic particles, allowing them to shift states and travel farther than expected. If true, this event didn't just break records. It may have revealed a hidden layer of the universe. 4. The cosmic microwave background might not be alone. For decades, The cosmic microwave background has been treated as the oldest light in existence, the afterglow of the Big Bang. But recent research suggests something unsettling. A small portion of that glow may not come from the Big Bang at all. Instead, it could include light from extremely ancient galaxies, blended into the background signal. Not enough to rewrite cosmology, but enough to raise an uncomfortable question. Have we fully separated the universe's earliest light, or have we been looking at a mixed signal this whole time? With more detailed maps coming soon, scientists may finally find out. Five, black holes are turning up all around us. Astronomers have long known about the supermassive black hole at the center of the Milky Way. Now, evidence suggests there may be another one surprisingly close. Researchers studying stars near the Large Magellanic Cloud noticed something strange. Some stars were moving far faster than expected, fast enough to escape the galaxy entirely. That kind of speed requires an enormous gravitational push. By tracing the star's motion backward, scientists identified the likely culprit, a black hole roughly 600,000 times the mass of the Sun. If confirmed, it would be the closest supermassive black hole ever detected outside our galaxy. Six, the universe might be rotating like a giant wheel. When astronomers study some of the oldest known galaxies, they notice a pattern. A large majority of them rotate in the same direction. Not a slight preference, nearly 2/3 spin clockwise. That raises a surprising possibility. What if the universe itself began with a built-in rotation? We already know rotation is everywhere. Planets spin, stars spin, galaxies spin. Extending that motion to the universe as a whole is a bold idea, but the data is forcing scientists to consider it. If the universe started with a spin, it could explain why motion appears at every scale. Seven, the Milky Way might be trapped in a gigantic void. There's a long-standing mystery in cosmology known as Hubble tension. When scientists measure the expansion of the universe using nearby galaxies, they get one speed. When they measure it using the early universe, they get another. Both methods are reliable, yet the numbers refuse to match. One possible explanation is unsettling. What if the Milky Way sits inside a massive cosmic void, a region with fewer galaxies than average? In that case, denser regions outside the void would pull outward more strongly, making nearby space appear to expand faster from our perspective. If true, the universe itself isn't behaving strangely. Our location is. Eight, we're using fast radio bursts to find hidden matter. For years, half of the universe's ordinary matter was missing. We could see stars and galaxies, but not the faint gas between them. Fast radio bursts changed that. These incredibly powerful flashes travel billions of light years. As they pass through intergalactic gas, their signals stretch and slow. By measuring that distortion, astronomers can calculate how much matter lies between galaxies. It's not a perfect map yet, but it's the closest we've ever come to locating the universe's missing material. Nine, the universe is showing signs of self-organization. For something born in chaos, the universe is surprisingly organized. Galaxies form long filaments. Clusters assemble into vast cosmic webs. Matter arranges itself into repeating patterns. This doesn't look random. It looks procedural. Similar patterns appear in living systems, from cells to ecosystems. On the largest scales, the universe behaves less like an explosion and more like a system slowly arranging itself. Ten, it's also evolving. Early space was simple, mostly hydrogen and helium. Today, it's filled with heavy elements, planets, oceans, and chemistry complex enough to support life. Each generation of stars creates new materials. Explosions forge metals. Metals build planets. Planets create environments. That's evolution, just not biological. It's possible that evolution didn't start with DNA. It may have started with physics itself. And this is only the beginning. In the next video, we'll explore 15 even stranger discoveries. From planets forming without stars, to lava oceans on distant moons, to hidden water deep inside Mars. The laws of physics might not be permanent. We tend to think of the laws of physics as eternal, fixed, unchanging, as if they were written into the fabric of reality once and forever. But what if they aren't? When scientists look deep into the universe and far back in time, something unsettling appears. The fundamental constants that govern reality may not be as stable as we assume. Constants like the strength of gravity, the charge of the electron, the fine structure constant that controls electromagnetism. These numbers determine whether atoms can exist, whether stars can form, whether chemistry and life are even possible. And yet, observations of distant quasars suggest that at least some of these values might have been slightly different billions of years ago. Not dramatically different, just not identical. Even a tiny change would rewrite the entire universe. If gravity were slightly stronger, stars would burn out too fast. If electromagnetism were weaker, atoms might never bond. If nuclear forces shifted, no carbon would exist at all. Which leads to an uncomfortable question. If the laws of physics can change, then were they ever truly laws to begin with? Or were they closer to conditions, temporary rules that emerged as the universe evolved? This idea shakes the foundation of physics itself, because if laws can evolve, then the universe is not a static machine. It's a process, and processes have histories. The universe remembers its past. The universe is often described as forgetful. Stars explode, galaxies collide, structures rise and vanish. But when scientists map the cosmos carefully, they notice something strange. The universe remembers. The cosmic microwave background, the faint afterglow of the early universe, still carries tiny temperature patterns imprinted just 380,000 years after the Big Bang. Those patterns didn't fade. They didn't blur away. They became the blueprint. The filaments of galaxies we see today follow those ancient fluctuations almost perfectly. Vast clusters formed where density was slightly higher. Cosmic voids opened where it was slightly lower. In other words, the universe never reset. Every stage left an imprint on the next. Even more strangely, some large-scale structures seem too organized to be random leftovers. Certain alignments stretch across billions of light years, preserving directional information from a time when the universe was unimaginably young. That means the present universe is not just shaped by physics. It's shaped by its memory. And memory is not a passive thing. Memory influences outcomes. It constrains what comes next. Which raises a deeper question. Is the universe merely expanding? Or is it carrying its past forward, shaping its own future? "13. Order keeps emerging from chaos. The universe began in violence, extreme temperatures, relentless expansion, constant collisions. By all classical logic, chaos should dominate. And yet, everywhere we look, order keeps forming. Particles arrange themselves into atoms, atoms into molecules, molecules into stars, planets, and structured systems. Galaxies don't scatter randomly. They line up along vast filaments, forming a cosmic web that spans the observable universe. This kind of order shouldn't appear so consistently, not without guidance, feedback, or self-correction. In nature on Earth, we see the same pattern: snowflakes forming perfect symmetry, crystals organizing from molten chaos, ecosystems stabilizing themselves over time. Physics explains how these patterns form, but it doesn't fully explain why order keeps winning, why complexity doesn't just collapse back into randomness, why structure appears again, and again, and again. At some point, coincidence stops being convincing. "14. Complexity keeps increasing. Early universe, simple. Hydrogen, helium, almost nothing else. Today, planets with atmospheres, chemistry, oceans, biology, technology. This is not a neutral trend. It's directional. Each generation of stars creates heavier elements. Those elements form rocky worlds. Rocky worlds enable chemistry. Chemistry enables biology. And biology enables observers, beings capable of asking questions about the universe itself. That trajectory looks disturbingly similar to evolution, not biological evolution. Cosmic evolution. The universe doesn't just change, it builds. Each stage enables the next. And once complexity appears, it rarely goes backward completely. Which leads to an unsettling thought. Maybe evolution didn't start with life. Maybe life is just one expression of a much older process. 15. Information might be more fundamental than matter. Here's where things get truly strange. In modern physics, matter keeps losing its status as fundamental. Particles behave like probabilities. Fields replace objects. Reality seems governed by equations, not substance. And increasingly, physicists are pointing to information as the true foundation of everything. Black holes obey information limits. Entropy measures missing information. Even space-time itself may emerge from informational relationships. Some theories suggest the universe behaves less like a physical object and more like a computation. Not a simulation, that's a separate debate, but a system where information is conserved, structures encode states. Complexity grows through processing. If that's true, then stars, galaxies, and even life are expressions of information flow. Which brings us to an uncomfortable realization. Information doesn't arise randomly. It accumulates. It organizes. It propagates. And systems that process information tend to develop structure. "16. The universe behaves like a system. Systems have traits, feedback loops, stability ranges, thresholds, phase transitions. And the universe shows all of them. Too much expansion, structure fails. Too little, collapse. Too much energy, chaos. Too little, nothing forms. Instead, the universe sits in a narrow corridor where stars, planets, and observers are possible, not guaranteed. Just allowed. That balance doesn't mean intention, but it does mean regulation. And regulated systems behave very differently from random ones. "17. Time might be directional for a reason. Time moves one way. Past gives present gives future. Physics struggles to explain why. Most equations work forward and backward. Yet reality does not. Entropy increases. Structures decay. Memory accumulates. But interestingly, complexity increases before decay dominates. Stars form before they burn out. Life appears before extinction. Civilizations rise before collapse. The arrow of time seems tuned to allow structure. Temporarily. Why? 18. The universe produces observers. This is the most uncomfortable fact of all. The universe allows observers. Not just once, not just rarely. Planets form in habitable zones. Chemistry aligns just right. Consciousness emerges. And then the universe becomes aware of itself. This doesn't require design, but it does require explanation. Why is the universe observable at all? Why can its laws be understood? Why do equations written by human minds describe reality so accurately? "19. We are inside a much larger structure. Every time we think we've found the edge, there's more beyond it. Solar system gives galaxy, gives cluster, gives supercluster, gives cosmic web. Each scale reveals another layer. And there is no sign that the nesting stops, which suggests the universe may be part of something larger. Not supernatural, just bigger. And finally, number 20, the question we can't avoid. After everything we've seen, one question remains. If the universe is not random, if it evolves, remembers, organizes, and produces observers, then what is it becoming? And what does that mean for us right now?